Hey everyone, and welcome to our lecture on loops. So in this lecture we're going to be covering what are loops, and loops are a way that we can repeat statements over and over again. And we do this based on conditions, so it's very similar in concept to what we learned about in our previous lecture about decision statements. And you may have already found yourself doing repeated statements over and over again, such as when we calculate the average of a bunch of grades, we had to input the grades 5 times, so we would have 5 repetitive input statements. This is a way that we could sort of cut out the redundancy of that and just tell Python to do this one statement 5 times, or these couple of statements 5 times. So one of the loops that we're going to learn about, and we're going to learn about two this semester, but the first one is a while loop, and it uses the keyword while, okay? And it's similar in structure to the decision statements, in that we have the keyword while followed by a condition, so something that equates to a Boolean value, followed by a colon. And then after that colon, we're going to have an indented body. And the body is what we're going to do while that condition is true. Once that condition becomes false, then we're going to jump over the body and pick up with the rest of the program basically on the same indentation level as the while was declared. So we can see that this hashtag here was dedented back to the same level as the while, so any statements here would be executed once that condition becomes false. So what we're going to do is we're going to start off just looking at some common loop algorithms. So there's kind of two high-level categories of examples we'll see. The first one is inspecting elements in a container. So with that, we'll look at how we can find matches, compare values, counting occurrences, counting or computing a total. And then there's also input. So with input, we can use loops to help us get a sentinel value. So if we're getting an arbitrary list of something, maybe grades, and we don't know how many grades that we're going to be inputting, we may tell the user to input a certain value like -1 to tell us when they're done. And that -1 is known as a sentinel value. And then another use case would be validation. So let's say we're playing a game like tic-tac-toe and we ask the user, do you want to play again? Please enter Y or N. If they enter any key other than Y or N, we can't really determine what their answer was. So with a loop, that allows us to go ahead and just keep asking them until they give us a Y or an N. And we call that input validation. So let's jump into some of these examples here. So in this example, we're just doing some simple counting. Okay. So we start off with a count variable. So count equals 0. This is what's going to hold the number of iterations that we've gone through. It's also going to serve the purpose of a loop control variable. And the loop control variable is something that is in the condition that we modify on each iteration. So we can see here the condition is while the count is less than 5, and if it's initialized at 0, we know it is. Then we'll print out the count, and then we'll add 1 to count. So this count plus equals 1, that's just shorthand for count equals count plus 1. All right, so we're incrementing count on each iteration, and that's serving the purpose of modifying the condition. So at some point, it's guaranteeing that this will become false. And we can see the output down here, 0, 1, 2, 3, and 4. I want to show you a neat little tool that I think helps visualize exactly what's going on here. There's a link in Moodle under our current module for this. It's pythontutor.com/visualize.html, and that lets us step through and sort of visualize what code looks like, as well as what the memory contents look like at certain points in the program. So when you load this up, make sure that you are on Python 3.6 and not 2.7 or any of these other languages. All right, and what I'm going to do is let's just get these two guys together. And let's put this code in over here. Let's say that count equals 0, so that's our counter. while count is less than 5, print the count, and then increment the count. It's a very simple example, so just so that we can understand what's going on here. All right, and once you have your code in here, you can go ahead and hit Visualize Execution. So we got a little legend over here. Red shows us the next line to execute. So next line is going to be line number 1. And green shows us the line that is just executed. Okay, and what we want to do is just step one at a time through this program. So we're just going to click forward. So when we click forward, we see that this line was just executed, and the next one is going to be line 2. And then over here in memory, we can see that in our global frame, so this is our memory contents, we have a variable called count, and its value is 0. Okay, so we're going to check that. Is count less than 5? Well, currently it is, so I fully expect this to go into the loop body here. And it does. It's going to go ahead and print out count, so we should see a 0 pop up here underneath the print output. And then we're going to increment count. So remember, this just adds 1 to whatever is already there. So if we do that, we can see that the contents of count has changed to 1. And if we keep stepping through it, we see it print out 1 and then change to 2. And as you can expect, eventually, when count equals 5, this program's going to end because there's nothing after this. And when count equals 5, 5's not less than 5, so it doesn't go into the loop body. Now, one common mistake that I do want to show you is a lot of people forget, especially when they're first writing loops, they forget to modify that condition. In fact, one of the things I recommend is while you're writing loops, as soon as you write the while and the condition, go ahead and at the bottom, go ahead and put in what you're going to do to modify that condition, the count plus equals 1, and then come back and write your body. That just ensures that you're not going to forget this. So what happens if we do forget it though, right? So let's get rid of it. And if we visualize this, we can already see that this visualize Python sort of detected that there's going to be an error. It stopped after running 1,000 steps. So that kind of clues me in that this thing's going to run for a very long time. And if we start stepping through it, we'll see it just keeps printing 0. And that's hopefully obvious. Why? Because we're not adding 1 to count. Count's staying at 0 the whole time. And what else is true about this? Count's going to always be less than 5 because we're not modifying this variable. So in this particular predicament, we call this an infinite loop, one that's going to go on forever. And one of two things will usually happen. You'll usually have to manually stop your program from running, or it will eventually crash. One of the two. All right, but they're pretty easy to spot. You would just see a bunch of zeros flowing down your screen, and hopefully you'd immediately say, oh, you know what, I'm stuck in an infinite loop. If you're running an idle and you get caught in an infinite loop, you can press Control-C to break out of it. All right, so let's look at a different example. Let's come back over here and let's put this back in, count plus equals 1. All right, so in this one, we're going to iterate over a container. So this one's actually a little bit different. Let me get rid of this, and let's start off. We need, we're going to use this index variable as our counter, like we did in the last example. So index of 0, and we're going to have a sentence, which is the quick brown fox. So this is our container. Oops. We're going to loop over this container, and we basically just want to print out each character on one line. So we're going to pull those out. We already know how to pull out individual characters, right? We use the index to address it and say, you know what, I want sentence sub index, and it'll give me one of these characters. Now, what can we make the loop condition be? So how am I going to know that I've looped over all of the characters? Well, I know the index positions start at 0, and they go up to, but not including, the len of this entire sentence, the full length of it. Okay, so I can leverage those two things. I can say, while the index is less than the len of sentence, I know that I'm going to be dealing with an index that's somewhere in here. And once the index grows out of this, then it's going to stop going into the loop. So just like before, we don't want to get stuck in an infinite loop. Let's go ahead and increment our index. So this is our modify condition. And then what do we want to do in the loop body? Well, we basically just need to pick out the character and then print it. So probably helps if I spell it right. Character equals sentence sub index. And then let's print out that character. Okay, so let's go ahead and visualize this. And if we start stepping, we'll get some things in memory. So we have that index here, and we have the sentence. And we're going to go ahead and check our condition. Yep, 0 is less than the len. Let's pull out the character. So this is going to be pulling the character out of sentence that's at index position 0. So we should expect that to be the T, right? And it does. It prints that, increments index, and then we go back and check our condition again. Okay, so this time, now that index is 1, when we pull the character out, we're going to get the H. And we'll print that out, increment the index, and keep going. And this process just continues. Let's see. Yep, we can hit last to just go ahead and jump to the end. And we'll see here that it did exactly what we intended it to do. It printed a character out on each line, pulling them out of this sentence. Alright, so those two were kind of really basic examples. Let's get into something hopefully a little bit more meaningful. So we're going to build off this one that we just did. And what we want to do is count the number of O's in the string. So the quick brown fox, and we can see the execution down here shows that there's 2, and we can go back and verify that there's 1 right there and there's 1 right there. So that is 2. But how can we do that programmatically? Well, we're still going to need that loop control variable, this index equals 0, but I'm going to create an additional variable that we can use to count the number of O's that we see. So let's start that off at 0, and we're going to call this num of O's. Okay, every time we see an O, we are going to add 1 to count. Alright, so down here, rather than printing out character, we still want to pull our character out, but then we want to make a decision. If that character is equal to an O, add 1 to count. And remember, this is the exact same thing as shorthand for count equals count plus 1. Okay? Now, we want to do that over each character in the sentence. We want to keep looking at each one. And once we finish, and only once we finish, do we want to print out the number of O's that we found. So when I get out of the loop, I know that I want to dedent back to the same indentation level that the while was declared on, and then just go ahead and print whatever it is I wanted to print. So I want to print the number of O. I'll use this %D, and we'll substitute back in the count. Okay, let's go ahead and visualize this one. So this one's going to start off roughly the same. We're putting some things in memory. We have index, count, and sentence. So it's remembering this for us. It's going to check our condition. We'll pull out a character, and then we'll look at it and say, hey, are you an O? This time it wasn't. We saw it jump down here, and it's going to increment the index. Okay, so that process is going to continue until, let's get to one where the character is an O. So we're at I right now. We got a couple more. space, so there should be B, R, O. Okay, so now our character is O. If the character is O, then look, it steps into this if statement and it adds 1 to count. Okay, so that's the first time we've done that, when it hit this O over here as part of brown. Now it's going to do it one more time when it hits this O, but we can go ahead and skip to the end and see that it prints out the number of O's is 2. So we were successfully able to basically count the number of occurrences in this container. Alright, in this example we're going to look at computing a total. So this is very useful. In fact, we've already used a function that does this for us. If you think about the sum function, that's exactly what the sum function does. It looks at a container, it adds up all the elements in that container, and then it returns to us the total. Well, let's go ahead and implement that logic ourselves so that we understand what's going on behind the scenes when we call the sum function. Alright, so just to get this set up, we're going to start off with a container that has some values in it. So 1, 2, 3, 4, 5. And then, similar to the previous one, we're going to want a counter variable. So I'm going to call this total in this situation. We're going to use this as a counter. And then we're going to need a loop control variable. And lots of times loop control variables are called I. Okay, so loop control variable. Now, we need to loop over the whole container. So that is a familiar thing that we've done already. We can just say while I is less than the len of our container, do something. We want to make sure that we modify the loop control variable. And specifically we want to increment it so that at some point this condition becomes false, or else we know we get stuck in an infinite loop. So total plus equals value sub I. So I'm going to pull out the current number here, value sub I. It's going to give me one of these, and I'm going to tack it on to whatever total has been previously. Once we get out of the loop, we'll dedent back and we'll just print out that the total is whatever's stored in total. Alright, so let's step through this one. So we'll start off just throwing our stuff in memory here. So we got this values. Notice how the list gets put into memory here. We have values and it points to this list that we can see the index positions above it. This 0, 1, 2, 3, 4. Those are index positions. And then what's underneath the index positions are our values. So 1, 2, 3, 4, and 5. I'm not sure where that arrow went. Okay. So we do our check, and yes, 0 is less than the len of this. The len of this is 5. So we want to go ahead and pull out value sub I. So value sub I is going to be 1. And then we want to add that on the total. So 0 plus 1 is 1, and that's what should be stored in total after that line. Then we're going to increment I and then check our condition again. We check our condition, we pull out value sub I, value sub 1 is 2, 2 plus 1 is 3, so after executing this line, 3 should be stored in the total. Okay, awesome. Now we had the 3 there, and we're just going to keep iterating through all of the numbers here in this list. Once we get done, so I equals 5, that happens to be the len of values, so it's not less than the len of values anymore. We'll jump out over here and we'll just print out our total. So the total is 15 in this case. So notice, if we wanted to, we could, just to show you, we basically implemented the same logic that is here. sum of values will do the exact same thing that we just did. And if we look at that, let's just jump to the last, we see that total is 15. Alright, so this next one's pretty neat. In this one we're going to be comparing values in a container. And what we want to do is look at this whole list right here and programmatically figure out what's the smallest number and then also what's the largest number. So we can already see that -7 is the smallest, 12 is the biggest, and with a list this small it's really easy for us to look at that and just sort of figure it out as a human. But imagine if there was 1,000 numbers in this list, or 2,000 or 100,000. That gets pretty difficult, and that's the whole purpose of writing something out programmatically. So let's look at this. We want to create our container here. And then the technique I used is I go ahead and say, all right, I'm going to pick, well, all right, let's think about this. We need to look at all of these numbers in the list, right? And we want to figure out which one's smallest and which one's largest. So what we can do is say, if I'm looking at all the numbers in the list, let me just start off by assuming the first number is the largest and the first number is the smallest. And then as I look at all of the numbers in the list, if I find one that's larger or smaller, I'll just update what the largest one is or what the smallest one is. Alright, so that in a nutshell is what we're about to write here in Python. So let's go ahead and determine what's the largest. So the largest, we're just going to go ahead and assume that it's the first number. Same thing here with the smallest. Alright, so that's where the num sub 0 came from. Now, let me initialize my loop control variable. Notice I'm starting it at 1 this time instead of 0 because, well, I've already looked at the first number and I've already said that's the largest and the smallest, so there's no reason to look at it again. I want to look at the numbers from index position 1 on. Okay, so that's the purpose of starting there. And let's say while I is less than the len of nums, that's going to let us iterate over all the index positions. Let's go ahead and modify our condition here. And then we just basically need to do two decisions, right? So let's expand on this just a little bit. Let's say our current num is num sub I, okay? So that's going to pull out like this one, and then this one, and then this one, and we can compare that to this largest and smallest. So let's say if largest is less than the current num, well, that indicates to me it's not the largest anymore, right? Current num is clearly bigger than largest. So let's update largest to be the current num. And we're going to do the exact same thing for smallest, except for we're going to flip our sign. So if the smallest number that we've seen so far is greater than the current number that we're looking at, well, we have a new smallest number, don't we? So smallest equals current num. Okay, we'll get rid of some of the spaces here. And we'll dedent back, and we can just go ahead and print out smallest %b, whatever's stored in that variable. And the same thing here for largest. Awesome. So let's see how this runs. Let's go to visualize, and let's start stepping. Okay, so we have our nums list thrown into memory. We go ahead and pull out the first one and say, hey, you're the largest, you're the smallest. Our loop control variable, and then we start looping. So let's pull out the next number, 3. And as we go through, let's ask, is that largest number less than the current number? No, not in this case, but is the smallest number greater than the current number? And that is the case. So now let's say that the smallest number we've seen is this 3. So that's why we changed that there. We see it's been updated. Increment I, and we go back and do it again. So now our current num is 5. Well, still not the largest, not the smallest, so let's loop again. Now our current number is -7. That's again going to update our smallest. And at some point here we'll hit the 12, should be this time, and is 10 less than 12? Well, it is in this case, so we're going to update largest. Okay, so hopefully you get the point of what's going on here. I'm going to go ahead and skip forward to the end, and we can see that the algorithm's able to figure out what's the smallest number and what's the largest number. All right, so in this next one, let's look at doing some inputs. So I do believe we can still do this over here in the interactive prompt. Or I'm sorry, not the interactive prompt, but over here in Visualize Python. Let's deal with a sentinel value. So let's start off with an empty grades list. This is very similar to a lab that we've done previous. And let's print out and say enter grades, then -1 to quit. So that -1, is what we call a sentinel value. It means something to us other than the intended purpose of all the other inputs that someone would be giving us. That -1 explicitly means that you are done entering grades. Okay? So how can we write that? Well, grade equals, obviously this was a design decision. Grades can be floats because we can have like a 97.8 or something like that. So we'll take it in as a float. Let's ask the user, input something, give me a grade, convert it to a float, assign it to the grade variable. And then while that grade is not equal to -1, okay, what do we want to do? While that grade is not equal to -1. Well, I want to just add it on to that grades list up here, right? It's empty now, but I want to add things to it. Now, in the previous examples, we've been using counting and like this less than relationship, so we've always just been adding 1 to the loop control variable. But in this case, what's the loop control variable? What can we change here in this condition? Can we change the -1? Well, no, not really. It's hard coded, so we'd have to change it here, and it would always be -2 or something. But there is a variable that we can change, and that's grade. So the way that we change that is we allow the user to enter another grade. Okay? So hopefully you can see now they give us a grade. If that grade's not -1, we add it to the list and we get a new grade. And we check, is that -1? Well, if it's not, let's add it to the list and get another one. When it finally is -1, then we'll jump out, we'll dedent back, and we can go ahead and compute the average as the sum of grades divided by the len of grades, and then just print out that the average is %.2f, whatever APG is. All right, so let's try to visualize this. We're stepping through it. We got our empty list. We're going to go ahead and prompt for a grade. So it's asking me down here for the grade. And let's say 100. Okay, so that pulled it in. We can see it stored it in memory as a float. So we see the decimal point there. While that grade's not -1, which it isn't, it's going to go ahead and append it to the grades list. Okay, so boom, we see it added there. Now, let's go ahead and ask for another grade. So what's the next grade? Well, how about 95? All right, now we see a 95's been added into, or stored in the grade variable. We're going to ask, is that not -1? It's not, so we'll go ahead and append that to the list. All right, and just for keeping it brief, let's go ahead and put in -1 now. So when we put in -1, we can see that's what's stored in the grade. Let's compare it. and see does grade equal -1. In this case it does. Then we're not going to do the loop body, and we're going to jump out of the loop and come down to line 9 and go ahead and compute the average and print it out. Alright, so that's a great technique for taking in an arbitrary number of grades. I could put in 100 grades here, I could put in 10 grades, I could put in no grades if I wanted to, and just put in -1. And it's going to work for all of those. So it's a very flexible solution that you can use. Okay, so this is just another example. We'll just walk through talking about this one. In this one, instead of using a sentinel value that's numeric, so let's say that negative grades were valid, so maybe in some other sort of example, any number on the number line would be a valid input, then we'd want to use something different. And we might use a character to represent the fact that we're done entering things. So in this example, we're going to use Q to quit. So enter grades, and when you're done, just enter Q, and we'll know that you're done. So we have to be a little bit more careful here, because in the previous example, look over here, we were taking in the input and immediately converting it to a float. Well, if I try to convert a Q to a float, I'm going to get a type conversion error, and it's going to go ahead and just basically blow up on me. It's going to complain. Well, we know that we can input strings, or inputs come in by default as a string. So if we don't do the conversion yet, we don't have to, we don't convert it to a float, we just bring it in as a string. We can then check to see, is it not Q? And if it's not Q, then let's convert it to a float, append it to the grades list, and then we'll get a new input. Alright, so really the only difference here is we just needed to wait to convert it to a float after we've discovered that it is not Q. Alright, so there's some other errors that we could run into here. What if somebody entered Y? What if someone entered T or a different character? Then it would blow up here on this line because it wasn't Q, but it also wasn't numeric. So those are things that we should think about as we're writing programs. Not necessarily something we have to worry about right now, though. All right, so last example here, let's look at input validation. So I had used that simple example over playing tic-tac-toe. Would you like to play again? Well, here's sort of a small snippet of that. So we're at the end of the game, and we need to figure out if the user wants to proceed. Do they want to play again? So we can create a variable called proceed and just set it to an empty string. And then we can use this in operator. So this is a nifty little trick we can do, is we can basically say all of these things are acceptable inputs. Capital Y, lowercase y, capital N, lowercase n. So if it's any of those, we're good. But if it's not in there, then we want to keep asking them to enter Y or N. Okay, so while proceed is not in capital Y, lowercase y, capital N, lowercase n, ask them if they would like to proceed. Would you like to continue? And I usually put out there, what are the valid inputs? So Y or N. And then just to prove that we got out of the loop, we're going to print out of the loop. Okay, let's go ahead and visualize this. So step, we got our proceed. While it's not in there, is the empty string in there? No. So we'll step into the body here, and it's going to ask us for something. Let's say that I enter A. So we can see A is stored in proceed. Is A in the list? No. So it's going to go ahead and prompt me again and say, would you like to continue? And this time I'll enter N. And we can see then, once proceed is in, well, the n is in the list. It goes ahead and gets out of the loop and prints out of the loop. All right, so that's an excellent way that we can do input validation. The next little topic I want to explain is, we've been doing a little bit of this. We can do nested loops. So nested, not like a bird's nest, but nested is in like one inside the other, sort of like Russian dolls. So it's very common that we nest various control structures within each other. As a matter of fact, we've already seen an example of this where we have an if nested inside the while. So notice when we nest something, we just have to keep up with our indentation levels, right? So this had to be indented 4 times because it was part of the loop body, okay? And then we did an if, colon, and then we had to indent this 4 times to show that it belongs to the if body, right? So in total, it was actually indented 8 times, all right? But essentially, the body just has to be indented from the control structure that it's associated with. And when we have these control structures inside other control structures, like the if inside the while, we call that nested. Okay, so similar to the last example we just looked at, we can have a while inside a while. Or we could even have a while inside of that. There's no limit to how far we can nest. The only thing we want to do is be careful of our indentation levels, like I was just talking about. Just make sure that each body is indented at least one level. Okay, so here's our nested loop example. And let's type this in here just so we can see it happening. So we got 2 different lists going on. We have letters, A and B, and we have numbers 1, 2, and 3. Well, the first one, I want to loop over my letters, okay? So I'm going to use I as my loop control variable. Loop control var for letters, and while that I is less than the len of letters, I'm going to do something. And I'm actually going to go directly into another loop, okay? So j equals 0. J is another common letter used as a loop control variable, especially after I has been taken. So this is going to be my loop control var for numbers in this case. So while that j is less than the len of numbers, then what I want to do is just print out, let's print out a string followed by a number. Okay, this needs to go in a tuple. We'll do letters sub I, numbers sub j. Alright, and then just like before, on each iteration, I should have already done this. J plus equals 1, and then at the end of the initial while loop, I plus equals 1. And then when we get out, we'll print done. Okay, so what I want to show you while we go through this and we visualize it is that we're going to go into this first while loop. I is going to be 0. We're going to immediately go into this next while loop with j, where j will be 0. We are going to exhaustively go through this loop until we reach the len of numbers. At that point, and only at that point, will it kick out, and then we'll go to the next I. Alright, so if that didn't make sense, hopefully seeing it will. So we got our 2 lists in memory. We got an I. We're checking, is I less than letters, or the len of letters? Yes, it is. We create a j, so that's our other index position. That's less than the len of numbers, and now let's start printing out. So the first letter, first number, so A1 is what we should see printed out, and it is. And then we're going to get a j plus equals 1. So we're going to increment j to 1, but notice where we went. We went back to this condition for the nested while loop. We did not go back to this one. All right, we will here in a minute, but first we have to finish going through this while loop. Okay, so now we have A2, And then there's one more, so j is 2 now. And we're going to print out A3. Now that j is 3, this while loop will become false. And now we're going to increment I. So now I is 1. And we'll come back up here. Is 1 less than the len of letters? Well, it is. J equals 0. We start going through, and now we got B1, B2, B3, and then we increment I. All right, and that's all of our letters. So since I equals 2, 2 is not less than 2, we come out here and we just print done. All right, so there's lots of interesting cases where we'll use nested loops or other nested structures, especially like decisions within here, or you can even do loops within decisions. All right, so all of that's fair game. Just realize that you can do that and keep up with your indentation levels. Here's another sort of silly example of some ASCII art. I'll leave this as an exercise for you to type this up and sort of step through it in Visualize Python and make sure you understand what's going on. And then here's an example that sort of builds off everything that we looked at here today. So we have some input validation going on here while the number is not Q. We're going to do that same process where we convert this character, or the string, into a number after we check to make sure it's not Q. So same as the input validation example. And we're going to print out the multiplier. So we'll start a new loop, multiplier equals 0. Notice that this is our loop control variable. We see it here in the condition. We're also incrementing it by 1 on each iteration. So what's going on in this nested loop? It's really not that complex. It just looks big. We're computing a product, so the number times the multiplier, the number they entered times whatever multiplier we're on. We're going to print that out. Number times multiplier equals product. Okay, so that's where that came from. I am modifying what the end is here so that we can print these things on the same line. Okay. Multiplier plus equals 1, that's just modifying our loop control variable. And when we get out of this nested loop, we are going to do another print. So that's going to effectively send the new line character that normally gets sent with this end. So end equals \n. Remember, that's the default. So this just prints a new line character, and then we'll grab a new number. So looking at the execution here, we gave it 2, and it printed out all the way up from 2 times 0 to 2 times 4, and then it prompted us for another number. Then we did 3s, and then we did 4s and 5s, and then ultimately we entered Q. So we entered Q here, and it came back up, and it said, oh, you know what, number is Q, so now I'm done. All right, so hopefully that makes sense. I'd also encourage you to take this one and throw it into Visualize Python just so you make sure that you fully understand it. And as always, if there's something that didn't make sense or something that could be explained better, please let me know. If not, I'll see you guys in the next video. Thank you.